Welcome back. We'll now do another example of a DTFT of a finite sequence. So again, like in the previous slide, we show you this finite sequence and we calculate the DTFT in two ways, by computer writing a program as well as a closed form solution. In this example, we have a sequence that looks like this. So this sequence is not very nice. It's still going from -4 to 4, but it's not symmetrical or anything like that. So we can't really reduce it very well. So I'm just going to show you the computer program to do this. This is the result. This is the magnitude, and this is for the phase. So I should write it down. This is the magnitude spectrum and this is the phase spectrum. Okay, and I'm plotting from 0 to pi, 0 to minus pi. So I'm plotting from minus pi to pi. So notice that it is always with respect to pi. And this one is the phase. This is also again from minus 2 pi to 2 pi. Alright, so now let's see how am I going to do this DTFT. Remember, DTFT is simply this equation going from n equals to minus infinity to infinity. Of course, since our index is from -4 only to 4, so again we are actually summing from n equals to -4 to n equals to 4, x of n, whatever value of this. So this is x of -4, x of -3, and so on, and this of course is x of 4. Okay, so and then e minus j omega n. So I told you that we have to do two for loops. So I'm going to show you where are the two for loops now. This is the for loop for the omega, and this is the for loop for the n equals to -4 to 4. So what we do is that we set the omega and we set it from minus pi, and we step until plus pi, and the step is equals to how many? In this particular example is I divided 2 pi into 501 step. Can you see? And I basically plot many values of omega, or I'm evaluating x omega at many values of omega. So see, I'm getting W now, and then I want to get my sum, which is x of omega equals to, later you'll realize it's the temp value. And then I'm calculating this temp value with this for loop, and this for loop is looping at the nine numbers in this sequence, finite support sequence from -4 to 4. So basically it is nothing but computing this value xn e minus j omega n. Can you see? By substituting different omega, different n, and I'm computing this and I'm looping this sum, and finally I'm storing this value, and of course then I later on will plot it here on the right hand side using these equations. Alright, now to be very clear, we always like to plot the horizontal axis with respect to a normalized omega pi, so it's omega divided by pi. Okay, that's why you go from minus pi to pi. Alright, for both the magnitude, so magnitude is gotten by the absolute value, and then the phase is gotten by the angle times angle with respect to the variable x, where x is x omega. So it's okay. So I guess this is it. So I got this example from Lati, and in Lati he also shows you that actually what I wrote in this like 10-20 lines of code can be gotten by this single line. Of course, we do not expect you to write such kind of equations, but you will see that the power of MATLAB can be exploited to reduce this DTFT into a single equation like this. Alright, but I prefer honestly for you all to write codes this way so that you all can see how to translate from the equations into codes and then using it to plot. Alright, thank you very much.